Right. Yeah, so Kubernetes in cloud native Kansas City. So who said that? Somebody said that? All right, so.
I was in the middle of typing that in.
Yeah, so this group is actually, what I'm trying to do is to get it to be part of the CNCF, which is the cloud native community. They kind of sponsor Kubernetes as well as a lot of other technologies, storage technologies, monitoring technologies, all were sort of a bent of going, being cloud enabled, those types of things. So yeah, so that's why it's Kubernetes in cloud native, because hopefully we'll get to talk about other things besides Kubernetes that are part of that ecosystem as well. All right, and so the plan for today, I'm going to walk through like an installation of a Kubernetes cluster, kind of show you guys, starting up a pod, starting up a replica set, some features like liveness probes, how you would look at like storage and things like that from a pod. And then after that, kind of spend some time for those who want to stick around and discuss what you guys want to see from this group. So I'm going to, if anybody is all interested in, giving talks or, has any ideas for things they want to do or places where we can host these things, that's kind of what this is for. So without further ado, I will get started on the walkthrough. Any questions before I get started?
How far are you?
You
running Kubernetes?
So yeah, what we'll be doing is on my home lab. So if anything crashes and burns, it probably means. I was actually really scared because we lost power this morning. I was like, that's great because this is all going to be running from my house. So it's wonderful. But power's back, so as long as we don't get any more lightning strikes, we should be good. All right, so a little bit of understanding about the lab environment. I made a video of my installation so I can kind of walk you through it. What I have at my house is a small little vSphere environment, which is like a virtualization technology that you can host VMs on. And what that allows me to do is to use something called Terraform, and that is a provisioning tool. I use that to spin up a whole bunch of nodes, and then those nodes, they're basically pretty much blank. They're just like Ubuntu 16.04 nodes. But once they're spun up, then I go and do the Kubernetes installation. But I wanted to show you guys that part so you guys got the full experience, but I wasn't brave enough to do the entire Terraform, destroy, and create, because that'd be really bad if that didn't work, because we couldn't do anything at all. So what this is doing, on the right-hand side there, that's the vSphere web interface. And so as Terraform is going through, what it's done is it's spun up a Kubernetes node, an NFS server for storage, and then 4 nodes to have the Kubernetes workload run from it. Does everybody know about Terraform and those types of provisioning tools, or? Okay. The primary reason I use it is just to save me a bunch of clicking, right? If I'm tearing down in my home cluster, if I'm trying different technologies and things like that, I'd rather use Terraform, edit one file, instead of having to go into the vSphere interface and right-click and destroy and do all that stuff over and over again. And so what you can see here is that on the left-hand side, it's saying which node it's working on, and then it's basically going through and doing apt-get upgrades, all the kind of things you do whenever you spin up a new node. And I'll actually show you the files that I use, the things that it execs, so you can see kind of just the base stuff that I do to these.
Saw the little cows and stuff.
Yep.
Those are like my Achilles
So is this all happening on your local machine, or is this all?
So I have a home server that I just sort of do all this on, but the same could be applicable to cloud providers and things like that. Cloud providers are kind of unique because some of them have Kubernetes specific technologies. So like you can spin up Kubernetes without doing any like OS installations or things like that. You can just say, spin me up a new cluster at places like Google, and they'll handle all this stuff for you. You just tell it how many resources you need. So yeah. So it added 6 machines. There we go. I sped it up a little bit. So it was 4 minutes, 20 seconds to do all that, but I sped it up to 2 minutes. 2 minutes, 40 seconds. And so what that gives us is...
What's the Kubernetes node?
What do you mean?
What's the bare like overhead for running a Kubernetes? Is there like called like a control plane of some kind, or?
Yeah. So right now.
Kubernetes node is like the master.
Yeah, exactly. So Kubernetes node is going to be the master. Right now, they're all pretty much the same. They're all just blank Ubuntu machines. Okay. And what we're going to go through is the installation part. So all that's been done to them so far is, so this is, like here's the, and if you guys are familiar with Terraform, I apologize. This is not pretty Terraform. This is quick and dirty Terraform. So yeah, what I'm saying here is, this Kubernetes node, it's got, I gave it 2 vCPUs, 4 gigs of RAM. I specified its MAC address and then ran these scripts on it. And this is pretty much the same scripts that I ran on all of them except for the NFS server because it's not going to get Kubernetes installed on it. So if you look at like this, I fix Ubuntu's weird, I've switched to systemd and I don't understand resolve comps anymore stuff, and basically do an apt-get upgrade, stuff like that. And then you look at the Kubernetes one. So this is what it runs right here. Just does install Docker. I add Kubernetes to the package resource list, so it says I now know where to install Kubernetes from. I add the key for it. I do some upgrades, and then I install kubeadm and kubeadm and kubelet, and those are the tools that we're going to use to install Kubernetes with. So think of kubeadm as like your installer file or your installer tool. And then down here are like different notes for different ways to set up your cluster, and we'll get into that. All right, so this is the first node, and what I'm going to do is I'm going to set it up with Flannel. So one of the first things if you're trying to set up one of these clusters on sort of like bare metal is understanding the container network interface. It's basically just a fancy way of saying, how do I want my pods to talk to each other, and what features do I want my networking layer between my pods to have? Flannel's probably like the simplest. Just like a whole bunch of IP tables type stuff. Calico is a little bit deeper. It gives you like network policy stuff, so you can actually configure which pods can talk to which other pods and things like that, and so on. So Weave's kind of the same way. It gives you that as well. Just basically more advanced technologies for your container, like how they communicate. And if you guys have questions, feel free, just pipe up.
Are these all supported at the same level by Kubernetes?
Yep.
Or is it the other direction that all these technologies have implemented support for Kubernetes? You know what I mean? Like the difference?
So all of these conform to the container network interface specification, right? Okay. But some of them support other clustering technologies. Like I think Weave, like they're a commercial product, I think.
Yeah, we use Weave with Mesos.
Yeah, so they support other clustering technologies as long as it As long as the technology conforms to the CNI, then it's going to work with Kubernetes.
Okay.
So some are Kubernetes specific, some aren't.
You're going to be running Kubernetes on top, right? You're installing Docker on top.
Yeah.
Okay. Yeah, because actually what I've seen, when I started doing was just using Docker to do the networking. So you really, Flannel, Calico, Wheat aren't strictly necessary, right? Or are they solving a problem that Docker won't?
They're solving a problem that Docker won't, right? Well, I mean, Docker probably will with like, Docker has their own like swarm and stuff like that, but Kubernetes, it requires some sort of CNI, some sort of network interface to tell it how those things should communicate.
Well, yeah, you can define a local network inside of Docker.
Yep.
And all the pods, all the containers talk on that.
Right. This is,
This is about multiple servers.
yeah, this is node to nodes. Yep, yep.
It's not a single
That's like, that's the difference.
So the CNI is the interface for solving the problem of a multi-node Docker cluster?
It's the way they've abstracted the networking out of it so that you can choose your solution to handle the networking between the different nodes. Yep. All right, so right now what I'm on is the Kubernetes node that I spun up in, let's see if I have it, vSphere here. So that's this node right here. It's just Ubuntu Linux, and it's got nothing really set up on it. And I'm going to do this flannel part right here. And so I gave it a pod network sitter, which is like the network that I want my pods to communicate on. And I gave it an extra name for the certificate that it uses because Pandora.LAN is my home little lab network. Hmm? Yes.
Instance of it. I may be getting that.
Yeah, and you'll see in a little bit, we'll actually spin up a pod, and I'll show you the difference between a pod and like a replica set or something like that. And so it says, thanks, we've initialized the Kubernetes master, do these things right here, and then you should now deploy a pod network to the cluster. And that's what I was talking about for the CNI. So this part right here is what we're going to use. So I'm going to copy it and save it. And I'm going to SSH to the first node, paste it in, we'll just save that so I don't lose it. And what I'm going to do now is set up, basically, I'm not going to do a whole bunch of this installation stuff from this local node, so I'm just going to do the bare minimum and then set up my local computer to talk to it so I can show you some better ways to interact with your Kubernetes cluster. So I tell my kubeconfig, the tool, where the configuration is. And then I'm going to install the flannel CNI. Okay, so what this is doing is this is setting up all these different pods that are in the kube system namespace. This is like sort of your Kubernetes main system area of setting stuff up. And you can see right now, a whole bunch of them are running, except for kubeDNS, which is pending.
Does that come from Flannel, or was that there before?
Hmm?
Does that come from Flannel, or was that there before?
What?
The DNS pods.
Oh yeah, so it basically Flannel has to do, so the order of operations, what I always watch for is kubeDNS to actually start doing stuff. And so it doesn't do things until your container networking stuff is actually set up and working. So it's not going to give you any DNS stuff, so that stuff's not going to work unless the CNI stuff starts working. So once Flannel has finished doing its I'm up and running stuff, then hopefully kubeDNS will start doing stuff. Yep, and so you see now we have 3 of 3 running for kubeDNS. I like it. Cool, so once you have kubeDNS running, you can start setting up your other nodes. So if you take a look at kubectl get nodes, right now we have 1. Right, we have the one that we just set up. It's the master node. Over here, we saved that little join command that it gave us for the tool. And so I'm on node 1. I'm going to run that. It says, I successfully did some stuff. I'm going to try to join. So I'm going to watch over here. It says node 1 not ready.
So you use kubeadm because that was what you installed with Terraform?
Terraform was only used just to spin up nodes. That's just saving me getting into vCenter and right-clicking and turning on Ubuntu. Terraform didn't do really any of the Kubernetes installation besides setting up the repo and installing that tool, the kubeadm tool.
kubeadm and kubelet.
So kubelet is what runs on the individual nodes. It's it like manages your Docker instances, and then on all the nodes, then they have like the kube API, and the kube API talks to the different kubelets, and that's how the orchestration happens.
Okay.
Does that make sense? Kinda. Okay.
So is the ADM a daemon running on the Kubernetes?
It's an installation tool.
Oh, that's what you said.
Yes. Yeah. But kubelet does run on all the nodes.
Okay.
It runs on the Kubernetes master as well, because the master is running those Docker, those system things as Docker instances, and kubelet manages those. Cool. So node 1 is ready. So we now have a single node Kubernetes cluster. So what I'm going to do real quick is do the same thing on the other nodes. How many nodes did I give us? 4? All right. So what's doing, same thing. Basically, it's going and doing all the stuff necessary, getting the CNI so that all these nodes can talk to each other. Okay. They're all online and ready. All right. All right, so we set up our networking. All right, so what I'm going to do now is set up my Mac so that it can talk to the Kubernetes API so I can use my local terminal instead of having to remote in to do all my commands. Just find it easier that way because you can set up everything sort of the way that you want to. So I'll keep it in this. And so all I'm going to do, if you have multiple clusters, this isn't the way you would want to do it, but for just this lab, what I'm basically doing is I'm taking this admin configuration file and copying it to my Kubernetes configuration. If you have multiple clusters, this same config can have information for all of those, but doing this command would overwrite it. So if you have multiple clusters, you'll have to manually sort of append the stuff in there. Cool, so I should be able to do, so this is my local Mac now.
I have a random question.
Sure.
How did you open a new tab and stay in the same
There's a setting in.
Oh.
So I use terminal. I don't use iTerm. iTerm might be different.
Oh, okay.
So
There's a preference in iTunes.
yeah.
That's easy.
So yeah, now I'm on my local. I can do the get nodes, and I see the same stuff as if I were on the Kubernetes master server. And I'm going to do kube on my prompt so that I get sort of like cool where I'm working and what namespace I'm in information. And so if you start doing a lot of Kubernetes work, get this stuff set up because it saves you a lot of typing. So there's first I'll show this. Kube Context or kubectx, basically it's two tools that allow you to set which namespace and which context you're using. So another way of saying which cluster you're on and which namespace you're in. Namespacing in Kubernetes is a method of isolation so that you can say, you know, here's my dev namespace versus my prod namespace, or here's my, you know, app 1 namespace and here's my app 2 namespace. And all the things in those namespaces are going to be isolated from the other namespaces. And when you're working with the kubectl command, if you don't have a tool like the kubectx and kubeNS, you have to type in the namespace that you're working with every single command, and it gets really old really quick because it's a lot of typing. And then this kube ps1, this just tells you where you are. So it says, like if you're using Minikube, which is a local way of sort of playing around and getting familiar with Kubernetes, it'll tell you which Kubernetes cluster you're in and which namespace you're using. So kube on and kube off. And so that's what you see right here. So I'm Kubernetes admin at this Kubernetes cluster, and I'm in the default namespace. Go for it.
Do you have autocomplete configured for Kubernetes?
Yes, so another really important thing is autocomplete. So if you look at kubectl --help, they have a completion. This will complete pod names, it will complete namespaces. So whenever you're doing a command or something like that, you hit tab to fill in the rest of it for you so you don't have to type it all out. Because the pod names can get pretty gnarly, so it's good to be able to tab complete them. Oh, and along with namespaces, so when I do something like, so I'm in the default namespace right now, which you can see right here. So if I do kubectl get pods, it shows nothing because I don't have any pods set up in the default namespace. But if I do like --all -namespaces, there's actually all these pods that are running. They're just not in the namespace that I'm in, so I can't see them by default. So the first thing I'm going to show you is just creating a pod. This one is from that Kubernetes up and running book. And it's pretty useful, but this is what a pod manifest looks like. It's a bunch of YAML. So you have like the version, what the resource type that you're using is, some metadata name, the container that you're using, and then a whole bunch of container-specific things. And these can get really long. This is probably as short as you're going to see. So I just applied it to our cluster. So hopefully, so we have our pod up and running. And if we show a wide output, it'll even show us what node it's running on. So in our cluster on node 4, we are running this kuard thing. And so in order to actually interact with this, I'm going to do a port forward so that we can connect in and see what this thing is doing. So if I pull up in our browser, host 8080, nothing will happen. Oh, I think I'm port forward's wrong. Yeah, 8080. There we go. So this image, its only real use is for experimenting around with Kubernetes. So if nothing else, play around with this in Minikube or however you guys are doing your experimenting, because it will show you how to do things like expose environment variables, from your manifest into a pod, what those look like. It'll let you see the memory that you've allocated to a pod. What happens if you allocate more memory than you said that pod could use? What happens to the pod? What's it do? Liveness pods, or probes. So basically, pods can say, hey, am I healthy? Am I serving this thing on port 80? It can do HTTP checks. It can do like TCP probes, those types of things. But you can do, am I healthy? If not, take me out of, and restart, stuff like that. Readiness probes, same thing, just a different way. Basically, don't start sending anything my way until this check actually succeeds. It lets you experiment with local DNS, generate workloads on it, and then browse the file system. So it's really good for just looking around and experimenting with Kubernetes. Probably one of the better ways to do it. So the one that I showed you, still have it open, right here, this didn't have very many things enabled. Basically, all it had was this container port thing, which says listen on port 8080 for this web interface. The next one that we're going to do is this full right here, and this has a lot of stuff, right? It's the same image, but we're also going to give it connection to an NFS server. We're going to say, here's how many resources it should request. So Kubernetes at its heart is a scheduler, right? So in order to schedule something, you say, I need these resources, put me somewhere where those resources are found. And so when you specify those resources, Kubernetes, when it does its scheduling, it'll say, okay, node 3 has those things available, I'm going to send to node 3. Does that make sense?
What if nothing has those resources, what will it do?
It will just not schedule. And then, so limits, basically you're saying, don't allow this pod to consume more than these resources. So you can specify CPU resources and memory resources to sort of do hard limits on those.
Are those optional or required specifications, the resource request?
Those are optional, right? So
You can just let it run rampant and
yeah, 'cause I already did. So the first one that we did, I didn't put any of that stuff in there. And it's going to schedule it whether those nodes can actually support it or not. And so it's a good thing to understand your application so that you can say, my application truly needs these resources, schedule it, here.
You can put a policy on the space that will put a default if it's unspecified.
Right, yeah.
So you should get public service.
We also have a liveness probe. Basically what I was talking about, saying, is this application healthy? And then a readiness probe saying, is this thing ready to actually send traffic to?
I didn't follow. What's the difference between liveness and readiness?
Am I alive is your liveness. Am I ready to help you is your readiness. So when you're spinning something up brand new, sometimes it takes your thing a while. Like picture a Java web app, right? It takes like 2 minutes for this thing to actually start up. It has a readiness check to say, am I ready to actually start accepting things? And then a liveness probe, after the readiness check is done, the liveness probe says, is this thing still actually alive? Should I keep sending stuff to it?
So like your liveness probe example isn't going to come back until it's also ready to serve web requests. Like if it was the Java web app, it takes 2 minutes. You send /healthy at it, it's going to hang for 2 minutes.
I think in some cases maybe not.
I don't know. Maybe liveness probe until the readiness probe is done.
Yeah.
The
So
liveness would come first or something.
no. The readiness probe. So it's not going to do anything until it's ready.
Oh, okay.
And then once it's ready, then the liveness probe is going to say, "Are you alive?"
Kyle, are you going to talk about lifecycle at some point? Are you going to explain what happens if the liveness probe returns false?
Yep.
Or fails?
We'll actually try it out. Hopefully.
Okay, sorry.
No, it's good.
Meetup is intense.
All right, so we had we have our one pod up and running. This is the one that didn't have much, so I'm going to delete it. Make sure it's actually gone, and then we'll try to. It's flickering. We'll apply that fancy one. Oh, you're good. So I just applied this file, which is the more complex version of this. And we will see if this comes online. And so right now I'm typing all the commands out, but like if you're administering a lot of Kubernetes stuff, you're going to want to like make aliases or do sort of your way of doing things. But like, you know, like usually I just type like pods, and so you don't have to do like every time. But find like your way of doing things, and try to avoid typing as much as you can. So it says it's running, but it's not ready, and now it is ready because the readiness check passed.
But it was alive.
But we can't hit it. We can't hit it because we got to do that port forwarding again. And now we should have a bunch of stuff. So if we take a look at our resource portion right here, we'll look at this first. We said I want to be limited to 128 megs of RAM.
256.
Or, yeah, 256. So if I go to this memory thing and actually do this a different way too. So it's on node 3. So now this is, if you guys have used Docker much, basically this is kind of like your Docker exec command. I'm exec into the pod right now. So basically it's exactly like Docker exec except working with Kubernetes.
Did you see what a pod was?
Which is one to many containers.
A pod is one to many. Yeah, so a pod
You win.
is one to many containers, and because this only has one, if there was a pod that had multiple containers, you do a -C and specify which container you wanted to go into.
I thought the pod was insane. The first time I saw it, I was, oh my god, I need this.
That's not what I want to do right now.
It's like a high risk
No.
You're not running the edge? Docker edge release?
True.
Where did I mess up? I always mess up on live stuff. That'll work. My while loop isn't working. So what I'm going to do is I'm going to allocate more RAM to this pod than we've said. So what happens when we try to get more RAM? So we got an arrow here, and we got disconnected.
You killed the pod?
Where's the pod?
Where is our pod?
Open the pod bay doors.
So our pod is on node 3, which is where it was.
Already.
That node that is now back to regular 0.
Yep.
What'd you just run?
So I ran describe. It's like a way to kind of look into, get sort of a detailed output of, what is this pod doing. And so our last state is OOM killed. So OOM is the out of memory manager for Linux. And basically it said this thing passed what it was allocated, so I killed it. So if you guys have ever had that run on a server before, it can cause havoc because it's basically saying, I don't have memory, I'm going to kill whatever process I want to get rid of it.
Was that like a Kubernetes out-of-memory killer, or was that like the
So we said that this pod should only use, X amount of resources. And because it's really kernels and pods, and it's kernels and container namespaces and all that kind of stuff on that underside, the Linux system actually just killed it and said it's out of memory using the OOM killer.
It's a Linux kernel secret feature,
Yeah.
similar to the way Docker does it. Secret.
Right. So we have our liveness probe, and you can see the probe is being served on healthy. The probe will permanently succeed. So what happens if we set our liveness check, our health check for this pod to fail? So we said the probe will permanently fail.
Oh, those are HTTP statuses?
Well, let's set that actually.
Yep. Yep, so if you look at our describe right now, it says, warning unhealthy, liveness probe failed, HTTP failed with status code 500. If we look at our YAML, initial delay, liveness, failure threshold, how many times, all those kinds of things. So every 10 seconds, it's going to check. Failure of 3 times. And so it killed it, right? And restarted it. And recreated it, yeah. And so if you look at your kubectl get pods status, has a restarts count of 2, but it shows it's up and running again. If we go back to the web interface, it shows the probe will permanently succeed because it's actually, the pod was completely recreated. So it doesn't know anything about us telling it to die.
So if there's a failure or something along those lines, something is restarting, and then allocate resources or release in a busy environment, those resources will be claimed by something else, and then it moves to a different code entirely. So swap,
So the goes to another node completely is the part where you might get tricked. When Kubernetes schedules a pod to a node, that pod stays on that node. So when it dies and recreates, it stays on that thing. There are other, so a pod is kind of like a lower level construct in Kubernetes. And I'll show you in a little bit replica set, which is basically sort of like the next step up, and your replica set manages your pods. And so that will give you sort of a bigger abstraction to making sure that you can have like 3 of these things running.
Would you sort of like exponential backoff?
Yes, it has a crash loop backoff. So if you have an application that's dying a lot, basically instead of restarting every 5 seconds or whatever it's trying to do, it'll stagger how long. So the first time it'll do like 5 seconds, and then 10, and then it'll just keep going and make it so it doesn't restart and kill your machine if something's going bad. Is that the longest it'll go? Yeah. Yeah, and I think it's a tunable parameter too. So. Yeah. So the next thing we can look at is the readiness probe. Make this fail.
Pronounce that kuard?
Yeah, kuard. I mean, it's actually just Kubernetes up and running. Demo, yeah. Because it's from the book Kubernetes Up and Running.
Yeah, it never gets that.
How do you pronounce the command? That's the real question. Is it kubectl?
Oh, it's cube control.
Or is it kubectl?
Yes, a lot of people say it's kubectl.
What?
Yeah.
Kubectl's better.
Probably call it SQL too.
So I just switched it back to ready for the readiness probe, and that means that it should hopefully see it and bring it back into, I am serving traffic again.
So the readiness probe could be if like the pod is overloaded, not just if it's initially up and
Yeah. Cool. So that's that. And then that's not going to be it. So I'll delete this one out. And the next one that we'll look at is a replica set. And remember I was saying a replica set is just a little bit higher construct. And if you look at the YAML, so So this on this side right here, this is the pod, and over here is your replica set. And so they're very close. The difference is that this one, the kind is replica set, and the replica set basically manages templates of containers. So you have pretty much all the same information in it. It just gives you a template so that you can manage more than one instance of it. All right, so this one is running and hopefully will turn ready soon, but notice that it's not named this kuard right anything anymore. It's given a name, and then it also has this thing at the end, basically because it's spinning up, you know, the pod with random stuff at the end, because you could spin up, you know, 20 of these, right? And you wouldn't want the same name because that'd be really hard to understand. Soon that will go ready. Cool, so it's up and running, it's on node 2. I'm going to scale it now. So right now we have a bunch, and it's put them on, you know, the different nodes in our cluster. And instead of doing a port forward, what I'm going to do is I'm just going to expose it with a thing called node port. This is a way of sort of exposing the networking. And so what this does is it basically tells it to listen on every single node in the cluster on a specific port. So if you have an external load balancer or something like that that you're communicating with and you need to talk, something like that, a lot of the cloud providers, you don't use node ports. They have integrations with their specific load balancing technology. And so you'll use like a cluster IP, and then it'll just spin it up and handle the load balancing and all that stuff for you. So it gave us 32312. So if I go to like node 1, but if I go to node 2, node 3, so because it's a node port, it does the same thing across all the nodes. And even to the point where, so right now we have pods running on all the nodes. So if I do my scale again, I switch to 1. So there's only one pod running from this replica set. So I have one pod running on this node 2. If I do my node 3, it still works, because all the nodes will send the traffic to it. It's not trying to go to a specific one. It's not tied to that thing. And then I think I don't have too much left. So, question? No? The only other thing that I have to show is storage technology. So I set up a simple NFS server. So if we look at like, I just did an NFS server with one share. And so if we go to our file, so under data, I've mounted this NFS share. So if we go to the web interface again, and you look at the file system browser, and we go to the data directory, we have the hello.txt that we put in from the NFS server that exists right here. And that is pretty much what I have for the stuff that I wanted to kind of cover with you guys today. Pretty quick. Go ahead.
What was the mechanism that forwarded the traffic to where the one running container was? Is that just native to replicasets? When you went to a node where it wasn't running?
So it's native to services.
Native to services.
Yeah, which is a construct in Kubernetes to handle that kind of stuff. Yeah.
When you were to expose, it creates a service for purpose.
So yeah, a lot of the things that you'll see in Kubernetes are abstracted like that, where instead of it all being one thing, like a service can be tied to, because they sort of did it at different levels, you can attach it to different things. So like pods are useful in replica sets, but they're also useful in daemon sets. So because they split everything out, everything can make use of the pod construct. So more than one thing can make use of like the service constructs.
Even though you only had running on like node 2, you made the request on node 4. The request didn't actually go into the running container, right? So it wasn't running container. I'm just trying to, it wasn't like the enemy got redirected. So
They hit the service in the Kubernetes level, right?
Yes.
They hit some Kubernetes IP.
Yeah.
Kubernetes told where to go because it knew where the container was.
Yeah. So there's a service called kubeproxy, and the proxy service is what handled sending it that direction.
Fancy, it actually sets up an IP tables rule, so it redirects it across that flannel network to
So if you dug into the IP tables on node 4, I think is where you actually try to browse to. When you dug into the IP tables there, you can see that the entry that was dug in was sitting into the
yeah, on that port, all IP tables, and so it's very high performance.
It's just smart
Yep.
ones that figure out Kubernetes.
It's kind of interesting to just watch IP tables rules being listed
I'm
out
sure
as you're
it's-
making stuff.
I'm sure
It's
it's
just always changing.
Yeah, sure. And that implementation was specific to rewriting to the very beginning. There were like 3 different versions of there was Calico, Wave, and all that. Is how each of those implements change how that routing occurs, or are they all space?
So I don't think they are, so I haven't looked under the hood. I don't think they are all IP tables based because like Flannel is different from Calico. Calico will give you like an overlay network, and your overlay network, it will handle the routing between those things. So that allows you to do like network policy type stuff where you can say, you know, my front end servers can only talk to my back end servers, my back end servers can, or my, you know, middle tier, or you can just sort of do all your directions kind of however you want.
So Flannel versus Calico, what's a better terminology than flavors of Kubernetes? And what was that? What were the differentiators there? Like that was an installation step, right? You're choosing which Kubernetes to install. Or
Which network interface? Which CNI? Yeah. And so if you go to like, yeah, Kubernetes. Calico and Flannel. See if this will find the page. So yeah, there's a lot of.
So CNI is like a standard that Kubernetes publishes and then different projects in the top.
Yep,
Okay.
exactly. Yep, and then they can throw on as many features as long as they're conforming to that specific standard. Right.
Alright. Would you use Flannel versus Calico from a security standpoint? Specifically, Calico would be real explicit, or is that, I'm not sure the architecture would be running it much better than Calico.
So take this with a grain of salt because I haven't actually done benchmarks, right? But from what I understand, Flannel is going to be lower level, so it's going to be more performant. Calico is going to have your overlay networking, so it's not going to be as performant, but it's going to give you more of the security features that you're talking about. So it kind of depends what your application is doing and those requirements around it.
What networking you use will depend a lot on where you deploy.
True, yeah. So
If you're on Google, you're not even going to think about this.
yeah, they will hide that from you.
They'll have that set up. Just recently, they enabled, there's the Calico policy, and then there's the networking. So they recently enabled Calico policy on Google networking. So you can, what you can do with Calico policy